Guys, can you hear me? Can you able to see me, guys? Hello, guys. Can you able to see me? Just confirm once so that we can start. Hello, guys. Okay, you're able to see me, right? Okay, right. Good. Good evening, guys. Good evening, everyone. So, guys, welcome to 3000 practice problems. So, let me introduce myself. Myself, Praneet Kalyanam. I'm maths educator at Unacademy. I have 10 years of teaching experience in teaching IIT-JEE maths. I have worked in Narayana Chennai campus and Akash Bangalore, and I am from IIT Roorkee. Okay, good. Ayappan. Already we have discussed few advanced questions in previous sessions. Okay, don't worry. In this session also we'll discuss advanced questions. So guys, this is my Unacademy profile. You can search my name in Unacademy. You'll get my Unacademy profile. You can start following me so that you'll get all my special classes, notifications, and batches, courses. You can able to find all this. Good evening, Sharon. Good evening. Right. So, guys, if you are aiming for IIT-JEE Advanced 2021, so enroll for this test series, guys. This test series is only for IIT-JEE Advanced. So these questions are prepared by top educators of Unacademy, and you can find the analysis also, free analysis by the top faculty, and enroll this for free, guys. It is starting from December 13th, so everyone you can enroll for this test series. Hello Sharon, I am from IIT Roorkee, ECE, Electronics and Communications. Okay, right. Chalo guys, chalo then let's start. So this is the first question we have. Everyone, let's start doing this question. The matrix P is given and Q is given. The relation between B and Bij and Aij is given, and the determinant of P is given as 2. Then what is the determinant of matrix Q he is asking. Okay, so right, let's calculate matrix P. Determinant of P is, as it is a 3 by 3 matrix, it is A11, A12, A13, A21, A22, A23, A31, A32, A33. We can write it like this. But what about matrix Q, guys? Det Q we can write it as B11. But see, what is B11, guys? B11 we can write it this way directly. Why? Because the relation between B11 and A11 we can obtain it. Correct or not? B11 and A11 we can easily obtain here. Okay, so let me write it directly. Otherwise, we'll take one more step. Don't worry. So B11, B12, B22, B21, B22, B23. Once again, this is a B13, right? B11, B12, B13, B21, B22, B23, and B31, B32, and B33. Right. So now let's convert this in terms of A11, guys. So what is a A11? A11 and B11, what is the relation? We can write it like this. B11 is equals to 2 power 1 plus 1 into A11. Can I write it as 2 square into A11? Can I write it here? 2 square into A11. Can we able to write it this way? Right. Same way B12. B12 is what? 2 cube into A12. Here 2 power 4 into A13. And here B21 means again 2 cube into A21 and 2 power 4 into A22 and 2 power 5 into A23. Next 2 power 4 into A31, 2 power 5 into A32 and 2 power 6 into A33. Right. So can we take 2 square from the first row, 2 cube from the second row, 2 power 4 from the third row. Can we do that? Guys, can we do that? Can we take this 2 power 4 into 2 cube into 2 square into 2 power 4? Can we take common? First row, take 2 square common. If I take 2 square common here, 2 square into second row, 2 cube. Third row, 2 power 4. If I take it like this, what we getting it? A11, 2 times A12, 2 square times A13, and same thing. Here A21 and 2 times A22 and 2 square times A23, and again A31, 2 times A32, 2 square times A33. That's what we're getting. Correct. And again, second column we can take 2 outside. And third column we can take 2 square outside. If you take it like this, how much we get it, guys? Already here 2 square into 2 cube into 2 power 4 is 2 power 9. So finally we get it like this. 2 power 9 into 2 square into. Remaining everything is same. A11, A12, A13 like this. So total how much we getting is? This whole thing we can write it as 2 power 12 into. Can I write it as a determinant of P? Can I write det Q is equals to 2 power 12 into det P? So that's what he's asking. But here det P he gave. Det P he gave it as 2. Correct. So what is the answer, guys? Det P he gave, guys. Don't forget that det P. So today is the last class in matrices and determinants, guys. This is the 4th session in matrices and determinants, and it is okay, right? Yes, exactly. So when we calculate mod D here, mod Q here, mod Q is equals to 2 power 12 into mod P. Mod P value we know that it is 2. So total 2 power 13 we are getting it. So 4th option is correct. Clear? So after this we'll do statistics. Ashish. Statistics is very important topic and very scoring topic, guys. After this chapter we'll do statistics. Okay, right. Chalo. The answer for this question is option D. Okay, right. Next question. Next question, it is very easy question. It's a very easy question. Clearly we can say that det A cube. So do we have det A cube is equals to det A whole cube, guys? Can I write it like this? Right, but that is given as 125. From this, can I say that det A is equals to 5? Can I say that det A is equals to 5? Correct. Right, and let's calculate det A here. Det A, how much we getting it? Are we getting alpha square minus 4 is equals to 5? From this, alpha square is equals to 9. From this, can I say that alpha is equals to plus or minus 3? Simple question, very easy question, correct? Correct. Papu Mandal, yes, you're right. He got, I think, Supreme Court today gave justice, right? Good. Yeah, chalo guys, let's move to the next one. Yeah, this is the next question. Number of distinct real roots of sin x, cos x, cos x. Determinant of this 3 by 3 matrix is equals to 0. Let's solve this, guys. Let's see if we solve this directly, what we'll get without applying any row and column operations. Let's say if you expand it directly, let's see what we get. Sin x into, so tell me, otherwise maybe you can apply row operations also. Maybe one row operation we can apply it. Can we apply one row operation here? So tell me what row operation we can apply it, guys. Maybe R1 minus R2 or something we can apply it, right? Right. Let's apply R1 minus R2 will apply. In place of R1, we'll apply R1 minus R2. So let's see what we get it. Sin x minus cos x. Cos x minus sin x. And 0 we get it. And here remaining rows are same. Remaining rows we are not changing anything. Remaining rows are same. And cos x, sin x is equals to 0. Determinant of this is equals to 0, guys. Right, so can we take sin x minus cos x outside? Can we take this sin x minus cos x outside? Why? Because it is common in first, each and every element of first row. So remaining part is 1 minus 1, 0. cos x, sin x, cos x, cos x, cos x, and then sin x is equals to 0. Let's expand this. So what is the answer we're getting in? Are we getting second option? Okay, let's check it. Let's check it. So let's expand the second part, guys. First part anyway we got it. First part we got it, which is sin x minus cos x. We got it, and second part we'll expand it. Let's see what we get. Second part is sin square x minus cos square x, and then sin x cos x minus cos square x. That's what we're getting it. Correct now? Guys, are we getting this? Sin square x minus cos square x, and then cos x into sin x minus cos square x. Yes, this is what we're getting, guys. Okay, so one solution is equals to 0 if you apply. One solution we are getting is sin x minus cos x equals to 0. That is sin x equals to cos x. This is one solution. For this we are getting x equals to pi by 4. Okay, this is one solution we are getting it. What about the second one, guys? Let's try to find out the second one. When we try to solve the second one, what we're getting is, see, we can convert everything in terms of sine, or we can convert everything in terms of cos. So tell me how much you get. Otherwise, you can take this. If you take cos x common here, what I get it here? Cos x if I take common, I am getting sin x minus cos x, I am getting it. Again, you take sin x minus cos x common. So finally, what I get it is sin x minus cos x into, you can take this as common. So this is what we're getting is sin x plus cos x plus cos x. That's what we're getting it. Is equals to 0. Already sin x minus cos x equals to 0. We have solved it already. So remaining part is sin x plus 2 cos x equals to 0. That means tan x equals to minus 2 we're getting is. Tan x minus 2 means, do we have any solution for that, guys? Tan x equals to minus 2. Do we have any solution for this? So minus pi by 4 to plus pi by 4. Are we getting any solution for this? Tan x equals to minus 2. Correct only, right? Alright, one second. Here if we take cos x common, sin x minus cos x. Here sin x minus cos x if I take common, sin x plus cos x, sin x plus cos x plus cos x, which is sin x plus 2 sin x, 2 cos x. Correct. Tan x equals to minus 2 we are getting, guys. So tan x equals to minus 2 doesn't have solution in minus pi by 4 to pi by 4. Why? Because if x is belongs to minus pi by 4 to pi by 4, tan x belongs to minus 1 to 1 only. But here we got tan x equals to minus 2. So there is no solution for the second one, guys. There is only one solution. Clear? There is only one solution, which is x equals to pi by 4. So there is only one solution. Tan x equals to minus 2 doesn't have solution between the interval minus pi by 4 to pi by 4. Clear? So what is the answer then? Third option is the answer. Okay. This is a 2017 advanced question. Very important question. Let's see this question. Which of the following are not the square of 3 by 3 matrix? Suppose if it is a square of 3 by 3 matrix, let's assume that this is a square, suppose. Square of a square matrix. If it is a square of square matrix, a square is equals to square of a matrix. And if you calculate the determinant of this, det a square is how much, guys? Det a whole square. Compulsory it should be positive, right? Compulsory it should be greater than or equals to 0 only, right? Either it should be positive or 0. But when we calculate determinant of this, how much we getting it? Determinant of a square, if you calculate, minus 1 we're getting it. So is it possible, guys? Determinant of a whole square, can it be negative? Not at all possible, right? So first option is one of the matrices which does not possible to make a square of a 3 by 3 matrix, because we are getting determinant of this given matrix is coming minus 1. But if it is a square, determinant of this a square cannot be negative. So same way third option also if you calculate determinant of this, we're getting minus 1. So but determinant of a whole square cannot be minus 1. So third option also one of the options. Clear? Understood, no? Right, but B and D is fine. B and D, if you calculate, modulus of this is becoming 1 and modulus of this is becoming 1. So mod A square can be equals to 1. So there is a possibility for B and D, but A and C is not at all possible. So answer should be A and C. That's what he is asking. Which one of the following are not the square matrices, not square of a matrices with real entries? So first option and third option is not possible. Remaining two options possible. So first option and second option is the answer. Clear? Right, next. Next question, guys. 2015 advanced question. Which of the following values of alpha satisfies the given equation? So determinant of a 3x3 matrix he gave, but it looks very complicated to expand. If you substitute any value alpha and if you expand it and check it, it will take a lot of time. Verification will take a lot of time, guys. Why? Because as it is an advanced question, maybe multiple answer is there. We don't know how many options are there. So substituting each and every value and expanding it, it will take definitely a lot of time. So what we can do is, we need to try another method. Okay, right. When we expand this, let's see what we get it. When we expand this, we are getting like 1 plus 2 alpha plus alpha square. Next 1 plus 4 alpha plus alpha square. 1 plus 9 alpha plus alpha square. And then 4 plus 4 alpha plus alpha square. 4 plus 8 alpha plus 4 alpha square. And 4 plus how much we get it, guys? 12 alpha, no? 12 alpha plus 9 alpha square we get it, right? Oh, 1 second. Numerator is 9 alpha square we're getting, huh? Numerator we did wrong, guys. This is 6 alpha and this is 9 alpha square. Correct. Yes, numerator we did mistake. Okay, let me correct it. Let me erase and correct it. So this is 6 alpha and this is 9 alpha square. Yes, now it is correct. Right. 1 plus 2 alpha plus alpha square, 1 plus 4 alpha plus 4 alpha square, right? This is 4 alpha square, right? Here this is 4 alpha square. Next 1 plus 6 alpha plus 9 alpha square. Okay, right. Next third row. Third row is 9 plus 6 alpha plus alpha square. And then 9 plus 12 alpha, right? 9 plus 12 alpha plus 4 alpha square. And then 9 plus 18 alpha plus 9 alpha square. That's what we're getting it. This is equals to given as minus 648. So can we write it as product of two matrices? Guys, can we write it as a product of two matrices? Why? Because we have this formula, guys. Det AB is equals to det A into det B. We have this formula. So by using this formula, can we write it as a product of two square matrices? Product of determinant of two square matrices. Let's try it. So if we try it, we'll get it. Product of two square matrices. Okay, right. Chalo. So tell me, guys, first element may be, see, this into this into this should be this, guys. Correct? So tell me, what is the possibility for first row and first column? Let's check it. Let's check it. So tell me, can I take it something like 1 alpha alpha square into 1 to 1? So let's check it. Is it possible or not? Next, 144. Next, 169. Okay, let's check it. Is it correct or not? 1 alpha alpha square into 1 to 1, 144, 169. Okay, right. Next, Next it is like 4 2 1. Okay, right. So guys, let's check it. 4 to 1 or 4 to alpha square? 4 to alpha square, right? 1 second, guys. Four to alpha square. Is it correct or not? Let's check it, guys. Let's check it. So complete second row now we can calculate and verify it. So when we calculate it, 4 plus 8 alpha plus 4 alpha square matching. Next 4 plus 12 alpha plus 9 alpha square matching. Next last row if you can calculate, we'll get the answer. So tell me guys, what is the last row? Last row is like 9 3 alpha square. Is it correct or not? Let's check it. 9 6 alpha square. If you multiply it, we are getting or not, just checking it. How can we think that it is to express as a product of two determinants? Why? Because see, every term is having some common factors. You can see here alpha square, 4 alpha square, 4 alpha square, 4 alpha square, 9 alpha square, 9 alpha square, 9 alpha square. There are some common factors, guys. That's how we can say that it is possible to express it as product of two matrices. Yes, this is correct. So this way we can express it. This is equals to minus 648 alpha. That's what he is giving it. Now let's expand it. Let's expand it, guys. So this we can write it as second column we can take alpha, third column we can take alpha square. Alpha into alpha square is alpha cube into, so we can write it like this: 1 1 1 4 2 1 9 3 1. And second matrix determinant, let me calculate, guys. We can calculate it. So tell me, 4 9s minus 6 4s, which is 3 4s, which is 12, minus 1 into 18 minus 6, which is 12, plus 1 into 8 minus 4, which is 4. Yes, okay, we got 12 here, is equals to minus 648 alpha. So let's cancel. So if we cancel, let's see what we get it. So alpha square we get it, and let's calculate this part also, guys. If you calculate this part, first determinant, if you calculate, what we get it? Minus 1 we get it, minus of 4 minus 9 minus 5 we get it. Next plus 1 into 12 minus 18 minus 6 we get it. Okay, into 4 is equals to minus 648 alpha. Hello Abid. Right, so now let's simplify this. This is how much you're getting it. Minus 7 plus 5, minus 2 we are getting it. So minus 2 means minus 8 alpha square is equals to, finally what I am getting is minus 8 alpha square. So alpha getting cancelled, right? Here alpha is getting cancelled already. Minus 8 alpha square is equals to minus 648 we are getting it. So from this minus cancelled and 8 also cancelled. How much, guys? 81 alpha square, 81 we are getting, guys. What does that mean? Alpha is equals to plus 9 and minus 9. Correct now? Guys, is it clear? Everyone understood how we are getting the answer easily? We multiplied the given matrix, we expanded the given matrix and expressed it as a product of two determinants. And these determinants easily we simplified it. And alpha square is equals to 81, that is alpha is equals to plus or minus 9. Is it clear, guys? Isn't it? She didn't say that alpha is non-zero. Alpha can be 0 also, but in the given options, alpha is equals to 0 is not there, right? Nidhilesh, alpha can be 0 also. Yes, whatever you are saying is correct. Alpha can be 0 also, but alpha is equals to 0 is not there in the option. If 0 is there, directly we can say that, okay, 0 is the answer. But 0 is not there, right? Okay. Right. So let's move to the next one. So guys, 3000 practice problems including maths, physics, chemistry. Okay. So we started this 3000 practice problems, I think 2 months back we started. Right. So I think till now we completed almost more than 1000 problems we completed. We might have completed more than 1000 problems. And in the coming days we'll complete 3000 problems. Okay. If you follow all 3000 practice problem series, you can able to score well in final exam, guys. Mains exam and advanced exam. Okay. Mohammed, जेई मेंस के लिए ये दोनों चैप्टर एनसीईआरटी से ही पढ़ा. Okay. Right. See, for mains NCRT won't be enough, guys. For mains exam, if you prepare for NCRT, I think you won't get any advantage. Maybe if you don't have basics, maybe you get advantage. I mean, maybe you may get basics, you may get it, but it won't be useful for mains or advanced. So compulsory, you need to do objective problems. Right. Let's solve this question. Total number of distinct values of x which satisfies this given equation. Okay. Right. Let's see how we can solve this. See, guys, can we able to express it as sum of two matrices? Can we able to write it as sum of two matrices? Like this is one matrix, x, 2x, 3x, x square, 4x square, 9x square, 1, 1, 1. This is one matrix, and another matrix is x, 2x, 3x, x square, 4x square, 9x square, x cube, 8x cube, 27x cube. Can we write it like this? Is equals to 10. Can I write it like this? Clear? Okay, right. So now let's simplify this. So if you are trying to simplify, see first matrix, first column we can take x. Second column we can take x square. So finally we can take x cube common and we can write 1, 2, 3, 1, 4, 9, 1, 1, 1. We can write it like this. And the next second matrix, first row and first column. First column we can take x. Second row we can take x square. Third row we can take x cube. So total it is becoming x power 6. And the second row we can take 2. And the third row we can take 3. So final how much we getting, guys? 1, 1, 1 we getting it. And here 1, 2, 4 we getting it. And then what, guys? Tell me. This is like 1, 3, 9. Yes, that's what we're getting it. Correct. Right, next. So what we can do is, if we interchange two columns here, it will become same actually. This matrix determinant and this matrix determinant will be same. Why? Because if you interchange these two rows first, and then again you interchange these two rows, these columns, I mean these two columns and these columns. If you interchange two times, minus of minus will be plus, guys. Determinant will be same. So what I can do is, I can take this matrix common, that is x cube plus 6x power 6 into this matrix expansion. We can do it. When you do this, how much we get it? 4 minus 9 minus 5. Next 2 minus 3 minus 1, that is plus 1. Next 18 minus 12, which is 6. Yes, that's what we're getting, guys. So when you expand this, how much we get it? Finally, we get this x cube plus 6x power 6 is equals to 2 we are getting, right? So this is plus, right? Plus or multiplication on. So tell me how much we get it. This is 2 we are getting it. So 2 is equals to 5. Yes. This is what we are getting it. Now you take x cube is equals to some t, guys. Take some substitution here. You can take x cube is equals to t. In that case, are we getting quadratic equation? 6t square plus t minus 5 is equals to 0. So what is the possible value of t? Minus 1 is one possibility. And what is the other possibility? Other possibility is 5 by 6. Clear? So x cube is equals to minus 1. This is one possibility. And x cube is equals to 5 by 6. This is the other possibility. So here we are getting one solution and here we are getting one solution. Total two solutions we are getting it. Clear now? So guys, is it clear? X cube is equals to minus 1 will give you x equals to minus 1, and x cube is equals to 5 by 6. That is also giving one more solutions. Total 2 solutions we are getting it. Total number of solutions is 2. Clear? Right, perfect. Next, 2019 mains question. Guys, start doing this question. Matrix B is given. Matrix B is the inverse of A. So then sum of all values of alpha for which det A is equals to minus 1. So he is saying det A is equals to minus 1, guys. So can I say that A is equals to B inverse? Hello Harsh. Can we say that A is equals to B inverse? Correct. So he is asking det A. So but see guys, can I say that det A is equals to 1 by det B? 1 by det B, can I say it like this? Why? Because det B inverse is 1 by det B only. Correct. So from this, in place of det A, can I substitute 1 by det B? 1 by det B plus 1 is equals to 0. That means that det B should be equals to minus 1. Okay. We got det B value. But B matrix, we know it. Correct. The matrix B, we know it. So can we expand it? Can we calculate the determinant and equate it to minus 1? Correct. Hello, other. So tell me how much we get it. So when you expand it, det B is equals to minus 1. So tell me how much we get it. Minus 1 is equals to, I'll expand first column guys. Why? Because there is a 0 in first column. So we'll get the answer easily. 5 into minus 5 we get it. And then alpha into, so how much we get it? 2 alpha minus 2 na? Right, 2 alpha minus 2 we get it. Let's expand now. So when we expand it, are we getting a quadratic equation? 2 alpha square minus 2 alpha minus 24 is equals to 0, and then alpha square minus alpha minus 12 is equals to 0. So guys, tell me what is the alpha value we're getting in? Are we getting minus 3 and 4? Are we getting minus 3 and 4? So sum of these two values, minus 3 and 4. Why? Because sum of all values of alpha. So minus 3 plus 4 is how much guys? Are we getting 1? So 1 is the answer. Correct. Is it clear guys? Perfect. Right. Next question. Guys, start doing this question. Good evening, Divyans. Good evening. So guys, start doing this question. This is a 3 by 3 matrix, and matrix A, invertible, non-invertible. So to make invertible or non-invertible, we need to calculate determinant of A guys. If det A is 0, non-invertible. If det A is non-zero, then it is invertible. Clear? Yeah, this is for 2021 and 2022 aspirants guys. Okay, let's do this question. So we can take e power t from first row. Let's say if I want to calculate determinant of this, we can take e power t outside, we can take it from first column. Second column, we can take e power minus t. Third column, also we can take e power minus t. If I take it like this, what I get it? 1, 1, 1, I get it. Second column is like cos t minus cos t minus sin t, I get it. And 2 sin t, I get it. Okay. Second column I calculated. Same way, can I calculate third column? What is the third column? Sin t minus sin t plus cos t minus 2 cos t, I'm getting it. Correct now? So now we can expand it guys. Shajaman. Okay, Sajaman Khan. You have a question. Okay, so why don't you join my Telegram group and you can ask there. or you can come to my special classes and you can ask there. So guys, if you have any doubts, so daily evening we'll have special classes on Unacademy. So if you have any doubts, you can come and ask there. Okay. Right. So let's expand the determinant of this. So anyway, e power t and e power minus t get cancelled. And finally what I get it is e power minus t into. Let's find the determinant of this. So when you try to expand the determinant, how much we getting, guys? Maybe we can apply some row operations, column operations. Yeah, R2 minus R1 will do it. R2 minus R1, if we do it, let's see what we get. Here we get 0. Here R2 minus R1, if we do it, minus 2 cos t minus sin t, we get it. And minus 2 sin t plus cos t, we get it. Third row also, R3 minus R1 we can do it, 0 we get it, and 2 sin t minus cos t will do it, and then a minus 2 cos t minus sin t will get it. Correct? Hello Kamal. Right, so when we expand it, let's see what we get it, guys. When we expand it, det A is equals to e power minus t into, so tell me what we get it. 1 into minus 2 cos t minus sin t into minus 2 cos t minus sin t minus of 2 sin t minus cos t into minus 2 sin t plus cos t. Okay, right. This is what we're getting, guys. Correct. So what is the answer? Is it B? Okay, let's check it. So when we expand this, how much we get it? Let's see, guys. So e power minus t into this, I can write it as 2 cos t plus sin t whole square. And then this also we can write it as 2 sin t plus cos t whole square. So, but when we expand this, finally what I get it is e power minus t into, so when we expand it, 4 cos square t sin square t. Correct. I think here minus, guys, here minus. So tell me how much we get. Plus 4 sin t cos t plus 4 sin square t plus cos square t minus 4 sin t cos t. That's what we're getting. Now can we able to cancel these, guys? These two, can I cancel it? Finally, how much I'm getting it? Am I getting like e power minus t into 5 sin cos square t plus 5 sin square t? That's what we're getting it. So is it constant? Is it e power minus t into 5? That means it's a constant value, guys. Correct? It's just a constant value. Mains and advanced both, Muhammad. So it's a constant. That means it is always non-zero. Always non-zero means it is invertible for every value of t. For every value of t, it is invertible. Why? Because the determinant is non-zero. So we can say that it is invertible for all the values of t belongs to real numbers. Okay. Right. Yes. Second option is the answer. Next question, guys. Next question. A and B be two invertible matrices of order 3 cross 3 if determinant of AB A transpose is 8. So det AB A transpose is given as 8, guys. From this, can I say that det A into det A transpose? See, det A transpose is also det A into det B is equals to 8. Can I write it like this? Okay, we got it. This is for 2021, guys. 2022 also you can listen, no problem. Right, so tell me how much we're getting it. Next, determinant of A into B inverse is equals to 8. That means can I write it as det A by det B is equals to 8? Can I say it like this? Correct. From these two, can I calculate det A? So multiply these two equations. If you multiply these two equations, det A cube is equals to how much we're getting, guys? 64. From this, can I calculate det A? 4. So same way, can I calculate det B, guys? Can I calculate det B? Det B is how much we're getting it? Are we getting 1 by 2? Yes, we're getting 1 by 2. So det A, det B calculated. Now how much he is asking? What he is asking is determinant of B into A inverse into B transpose. This is nothing but det B whole square by det A only. Det B already we calculated and det A we know it. What is it? 4. So now tell me, total 1 by 16 we are getting it. So third option is the answer, guys. Clear now? Guys, is it clear? Right, perfect. Right. So third option is the answer, guys. So guys, is it clear now? Right. So perfect, guys. So that's it for today. So see you in the next session. Next section will be on Friday, guys. So every Monday, Wednesday, Friday we'll have a session. Every Monday, Wednesday and Friday night 9:30 p.m. we'll have the YouTube session for 3000 practice problems. Okay. So see you again on Friday. So Friday we'll discuss statistics problems, guys. Okay. Right. Chalo then. See you everyone. Take care. Good night, guys. Bye bye.